I want to use very few minutes maximum. I don't know whether there will be 30. Because physical properties of carbonyl compounds have been really taught. They have been really taught. So I am a bit lazy to go through them. Yeah. I don't know, maybe I stop it here. Stop here, I don't know. Okay, let me go through them very quickly because they have been taught under bonding. Yeah. So the first one is physical appearance. Physical state, shock appearance. So what are we going to say here? Of course, in bonding, they have taught you that the physical, you've been taught that physical appearance of a compound changes according to its molecular weight. It changes. Now, changes according to molecular weight. You will find out that methanol, this is a gas. Why? It has a very low molecular weight. Then the next, what? The next, those, aliphatic, because we also have those that are aromatic. Aliphatic aldehydes. Aliphatic aldehydes and ketones. Aliphatic aldehydes and ketones with aliphatic aldehydes and ketones with between 2 to they're around 6 or 7. I'm not so sure. Aliphatic aldehydes and ketones with between 2 to 7 carbon atoms exist as liquids. Yeah. There are also those that are aromatic. Now, if you are aromatic but you have fewer carbon atoms, for example, aromatic with fewer carbon atoms, for example, benzaldehyde. Benzaldehyde can exist as what? As a liquid. However, higher aliphatic aldehydes with between 2 to 7 carbon atoms occur as liquids. Higher homologies and the aromatic, higher homologies and the aromatic carbonyl compounds occur as solids. Higher homologies and aromatic carbonyl compounds occur as solids. That is physical appearance. Then solubility, these are covalent compounds. So you see, molecular, what is important to note here is that the state changes with the increase. It changes with increase or decrease in relative molecular mass of the compound. Increase or decrease in relative molecular mass of the compound. Then the other property of exploration is the part B, solubility. I want to say that lower homologies, like which ones? Lower homologies, e.g. ethanol, methanol, ethanol, propanone, propanol. Lower homologies like those ones are soluble in water. Lower homologies like those ones are soluble in water. However, now these ones, carbonyl compounds do not form hydrogen bonds. They do not form hydrogen bonds with the water molecules. Yeah, so they dissolve, but not all of them. Few of them, those with those examples which I have given. Then other carbonyl compounds. Other carbonyl compounds are slightly, if not fully insoluble. Other carbonyl compounds are slightly soluble, or insoluble. Slightly soluble, insoluble in water. Slightly soluble, insoluble in water. Due to the following. Due to, number one, due to increased relative molecular mass. Due to increased other carbonyl compounds are slightly soluble, insoluble in water due to increased RMM of the compound. Then increase in RMM increases number of carbon atoms. So increase in RMM increases hydrophobic, that increases hydrophobic portion. It increases hydrophobic portion of the molecule of the compound. Hydrophobic portion is the water heating. I've told you when you increase molecular mass, you are increasing number of carbon atoms. Those carbon to carbon bonds are non-polar. They are non-polar, they are water heating, they are hydrophobic. So increased RMM of the compound. They are slightly soluble, insoluble in water due to increased RMM of the compound that increases hydrophobic portion of the molecule. Then the other thing, they also they are insoluble due to they do not form hydrogen bonds. They do not form hydrogen bonds with the water molecules. They do not form hydrogen bonds with water molecules. They do not form hydrogen bonds with water molecules. I hope you know what a hydrogen bond is. I don't know. Let me know. Do you know what a hydrogen bond is? Some of you know. That's what I am sure of. There are some of you who know what a hydrogen bond is. So carbonyl compounds do not form hydrogen bonds with water molecules. Maybe let me leave this question behind. If it fails, then I'll come back and go through it so that I explain what hydrogen bond. Put a question here. I compare what? I compare solubility of what? I compare which one? Maybe butane. Okay. Explain why. A quick one. Explain why. Explain why butane 1-ol. Explain why butane 1-ol is in water. Explain why butyl alcohol. Butane 1-ol. Explain why butyl alcohol is soluble in water, whereas butanol as butanol whereas butanone. Why is butanone oil soluble in water, whereas butanone is slightly soluble, in water and other polar solvents. Let me first leave that question behind. If you can do it, well and good. But if you cannot do it, still you type in the chat. I'll go through it. I just have I just have a feeling that some of you know what a hydrogen bond is. Others don't know. So, but if all of you can do that question, then we are good to go. I will not explain that in detail. As of now, allow me stop here. And okay, maybe I leave that.